Well, let's keep going with this idea of simplifying square roots and leaving them in radical form. This is from section 3.9, so we're going to fill this in. We're going to write radical right here. And I would like to remind you, when we say radical form, another way that we could talk about that is we could say that we're leaving them in exact form. So keep that in mind. If anybody has a problem and they say, well, you need to leave the answer in exact form, if it's got a radical in it, we want to simplify the radical completely. So that's what we're talking about today. And we've already done problems like this, -2 times radical 49. So today's material is going to be fairly quick. It just turns out a little bit differently than this right here. Just a quick reminder, we had -2 and then radical 49. That's a perfect square, so we end up with 7 there. So the answer on this one is -14. So we get a nice integer for that one. But when we take a look at each one of these, maybe some of these simplify, some of them don't, but let's take a look at this one right here. The idea here is to get used to having a coefficient out in front of the radical and then still simplifying that radical the way we're used to, and then we'll multiply those coefficients that are left out front and we'll see what we get for a simplified answer. So the problem right here is 4 radical 18. So this is what we're going to do. We're going to leave that 4 out there and we're going to think about how we'd break this down. Remember, we want to take out pairs of factors when we're finding square roots. So I'm going to have 2 go in here, it goes in 9 times. We'd stop at the 2 because that's a prime number, and then we're going to break down the 9 into a 3 and a 3. So here's what this problem could be rewritten as. We've got the 4 on the outside, and then we've got the 2 and the 3 and the 3. Again, notice I need each one of these, the end of each one of these branches, and I can always double check by taking 2 times 3 is 6, 6 times 3 is 18. I know I've represented the same problem right here, and now we're looking for pairs of factors, groups of 2 right here. So I'm going to take that pair right there. So we've got a 4 on the outside that was already there to begin with. We've got the 3 that represents this pair of factors on the inside, and then the 2 stuck on the inside because, again, we don't have anything to pair that up with. So we multiply these together. We end up with a 12, a radical 2, and that right there is the answer, 12 radical 2. Let's take a look at the next one. So we've got a -3 outside, and again, if you can skip to right here, that's awesome. I'm going to put the -3 right here. I'm going to put a radical, and I'm going to say, okay, 3 goes in here. It goes in there 9 times, and then 9 can be broken down into a 3 times 3. So if you recognize that perfect cube, and again, don't get mixed up by the numbers or anything, this is 3 times 3 times 3. If you can do that before you do this, there's no need to show all of this work. If you know that a 27 turns into a 3 times a 3 times a 3, you're totally okay doing that. Let's take a look at this right here. Again, we've got a pair of 3's here, so I'm going to take out that pair of 3's. We've got a -3 times that. That pair of 3's is represented by 1 3 on the outside. That's what that radical does. That square root takes a pair of factors on the inside and turns it into 1 on the outside. And then we're stuck with this other 3 right here because there's no other 3's to pair that up with. We already took the 2 of those out. So we end up with a -9 and a radical 3. So -9 times radical 3. Next one, we've done radical 32 before. I'm going to write the 5 outside. I'm going to give myself a little bit of space. Remember, I'm going to break this one down a little bit differently. I'm going to do 4 times 8, 2 times 2, 2 times 4, and that's 2 times 2. So take a look at how many we have here. I've got 3 2's here and another 2 there. So I'm going to write down all of those 2's. And again, if you want to put dots in between there, that would be great. Pair of 2's here, pair of 2's here. So we end up with a 5, 1 2 represented outside for that group, another 2 represented outside for that group, and then we've got a 2 stuck underneath because there were 5 2's, not 6. There's nothing else to pair that up with. So when we multiply these together, this is 5 times, this would be 2 times 2 is 4, so 5 times 4 is 20, so we have 20 radical 2, and that's the answer. We want to be really good and really quick at getting these answers and make sure we get them right every single time. Now again, like I said, if you can write down all 5 of those 2's without showing this prime factorization, that's totally okay. So for example, on this one right here, I've got -5 on the outside, and then this would be 9 times 7. That's on our times table. So if you can break that up and you can think 9 times 7, and then we're just going to write 3 times 3 times 7. There's the 9 and there's the 7. And again, there's a pair of 3's. So we're going to have a -5 times a 3, and then the radical 7. That 7 is stuck underneath there. So we get -15 times radical 7. And there's our answer right there. Okay, last one on this one. This is 5 times radical 196. Now, if you recognize 196, then that's awesome. If you don't recognize 196 as a perfect square, then we kind of are stuck simplifying this. Now, remember, if you've got an even number, 2 will always go in there. So if you were to reach for your calculator and say, I need to know how many times 2 goes into 196, we do 196 divided by 2, you'd end up with 98. And then this is still even, so it's nice when they turn out even because we can just say, okay, 2 goes in there, and then we get to 49. Now once you get to 49, that should be pretty easy because that's a number that we recognize, so that would be 7 times 7. So we have a 5 on the outside, we have a 2, a 2, a 7, and a 7. So again, all of these ends of these branches right here on this factor tree. So we've got a 2 on the outside to represent that pair of 2's on the inside. We've got a 7 on the outside to represent that pair of 7's on the inside. And then again, technically what's left would be nothing. There would be a 1, which we normally don't write. So this is the answer right here. 5 times 2 is 10 times 7 is 70. Okay, so in that simplified version, it started out with a radical, but then we just get this nice whole number of 70, and we're all set to go. Okay, if you understand that, then I do want to show you something else that might be a little bit of a challenge, but I think you can figure this out. This is what most of the problems on the assignment are like, but let's see if we can figure out something that's a little bit more difficult. So a reminder, when we simplify square roots, we're looking for groups of 2 factors to take out of the radical. So if you use that same reason, if we're simplifying square roots and we're looking for groups of 2 or pairs of factors, when we simplify cube roots, then we're looking for groups of 3 factors. So we're looking for triples, if you want to call them that. So this one should look familiar. Again, we're switching to cube roots here. So this is going to be the cube root of, and we did 27 up above, 3 times 3 times 3. There's a group of 3 3's. Again, it's a cube root, so we're looking for all of those. So there would be a 3 on the outside. Again, technically what would be left underneath there would be a 1, but the cube root of 1 is 1, so this is 3 times 1. So the answer is just plain old 3. Or we can skip right to here and just say, hey, group of 3's on 3 3's on the inside is 1 3 on the outside, nothing stuck underneath, if you wanted to think of it that way. Okay, let's take a look at this one. Again, a cube root right here. 16 is, let's see, that would be 4 times 4, and that's 2 times 2, which would, and 2 times 2 there. So we have a 16 is actually 4 2's. So let's take out a group of 3 2's right there. So there's a 2 on the outside. And then that 2 is stuck there because there's nothing else to group it up with. We need 2 more 2's in order to take out a group of 3. So the answer on this one would be 2 cube root 3. This one here, this is 81. We might want to break that down, so I'd say 9 and 9, 3 and 3. So this is going to be similar to the one we just did, except for it's going to be the cube root of, it's going to be 4 3's multiplied together. So again, we're looking for a group of 3, 3 on the outside, and that other 3 stuck on the inside. So this would be 3 cube root 3 would be the answer there. Let's take a look at this one. This one looks kind of interesting. I'm going to break it up this way. This would be 25 times 10, and then this would be 5 times 5, and this would be 5 times 2. And I'm going to do something a little bit clever. I'm going to do this. I'm going to put the cube root right there. Okay, so I don't have to rewrite them or anything. I've got 5 times 5 to represent the 25, and 5 times 10 to represent, 5 times 2 to represent the 10. Here is a group of 3 5's. So there's a 5 on the outside, and then don't forget to put the index there. A lot of people drop that off there and they just write a square root. This is a cube root, so this would be the cube root of 2. So 5 cube root 2 would be the answer there. And then this last one. Again, it's an even number. If you want to break it up a different way, that would be fine. But I'm going to break this into 2 times 27, which again, we did 27 a minute ago. Whoops. It's 3 3's multiplied together. So this would be the cube root of 2 times 3 times 3 times 3. Group of 3 3's. So that's a 3 on the outside, and the cube root of 2 stuck underneath there. Okay, we're going to take a look at problems 1 and 7 from your worksheet today. Alright, so I've got the worksheet up here. The instructions for 3.9b, simplifying square roots. It says simplify each square root, write answers in radical form, no decimals. Okay, so we want to write this in exact form. We're not throwing this in a calculator and getting a decimal approximation for this. So you'll notice that we've got a 5 on the outside, so we've got that coefficient out there. And then 8 is 2 times 2 times 2. Okay, it's 3 2's. If you wanted to write this down as 4 times 2, and you could write that as 2 times 2 times 2. If you want to do a factor tree or something like that, I'm just kind of showing you the thinking that would go in here. So this is 3 2's multiplied together. Again, this is a square root. We're simplifying square roots here. So we're looking for a pair of factors here. So we have a 5 times 2, and then that other 2 is stuck underneath there. So we multiply the coefficients together, so we end up with a 10 radical 2, and that's the answer. Now I will say this, if you can write this work down and then skip directly, instead of writing 5 times 2, if you just want to write a 10, that's totally okay with me. But please make sure you're showing you're thinking about how you did the problem, that you're showing that you're taking out pairs of factors right here. Okay, let's take a look at number 7, down toward the bottom. Again, this is a fairly big number, but again, notice that it's even. We use that tool all the time to make the numbers smaller. You know, if we've got a gigantic even number, if we take out a 2, if we factor out a 2, it's going to make that number easier to deal with. So I'm going to break this down. I'm going to do 2, and then 2 goes into 108. If you need a calculator, that would be fine. 2 goes into 150 times, and 2 goes into 8 4 times, so this is 54. Again, that's even, so 2 would go in there. If you take 54 and divide by 2, if it were 50, it would be 25. And then 2 goes into 4 twice, so 25 plus 2, this is 27. And then again, I'm hoping that looks familiar. If you need to do one of these factor trees every time, there's no problem with that. Prime factorizing is a really good skill, so there's no problem practicing that. So we have an 8 on the outside, and let's take a look at what we have. Let's represent every one of the ends of these branches. We have 2 times 2 times 3 times 3 times 3. All of those are underneath the radical. It's a square root. Notice the index isn't there, so we assume it's a 2. So a pair of 2's, pair of 3's. So we have an 8, a 2, and a 3 on the outside. That last 3 stuck underneath there because there's nothing to pair it up with. This makes a 6. 2 times 3 is 6. Times 8 is 48. Radical 3. We'll circle that, and we're all set to go. All right, that's typical of the assignment, so good luck there.